Welcome back to another Let's Code. Today we're going to be finding a dependency inside of a workspace. So I do a lot of programming in JavaScript, and that means I have repos that look like this with tons of files, and inside of packages, I have a ton of packages, and each of these packages could have or be requesting a different version of a different library or something like that. So I want to write a tool today that will let me ask for what version a specific package is asking for. So for example, I have a package called dub right here at the bottom. So if I go packages, dub package JSON, and I'm using cat here, so we don't get the pretty output, but actually I should use open and get in the habit of doing that more. We'll get the dependencies. Oop, I didn't spell dependencies yet. Dependencies. There we go. And let's pivot this so we can take a look at it. And we get this readout of the dependencies and the semver versions that they are asking for. Now, I want to be able to come into this and be like, hey, what version of PostCSS is my dub site using? So to do that, instead of using new shell, which is what I'm using right now, we're going to write a Rust program because I like writing Rust, and getting better at writing Rust involves writing more Rust every day. So obviously, when I go to get started here, the first thing I need to do is update my shell. As any professional programmer will tell you, the first thing you have to do when using a computer you haven't used in a while is update all of your dependencies. So I'll see you in a second. And as ever, whenever we upgrade, we realize that some of our aliases no longer work. I happen to know why this one doesn't work. If I can remember which directory this is supposed to be in. You know what? I actually don't need to. Config path. So if I do code config path, and this is actually the problem with the command above. So I have an alias called gwip that will do a get add, get remove, whatever. And you'll see that I have a little $sign here. And we don't need the $sign anymore. We can just use parentheses, which is one of the really nice upgrades in new shell 0.34. So if I do that, it should open a VS Code workspace at that path. And then I can go down to really anything that has a $sign before it. We select all of these. I'm hitting Command D right now. So that will give me all of these, and which I can replace with just the paren. So if I save that and we reboot, we're good. All of our aliases work now. And I have now gone on a tangent to what I was going to do. So in the first place, what we need here is a new terminal. I'm going to back out of this christopherbiscardi.github.com repo. And I'm going to create a new cargo new yarn-get-dep. So this is going to be yarn-get-dep. You can see that we have a cargo toml inside of source. We have a main.rs. Very typical cargo setup for a Rust project. One thing that I do want to mention before we get started here, or I guess we are already started, but if we open package JSON and we get workspaces, the workspaces key in package JSON is a yarn workspaces declaration. I believe npm null also has workspaces. I haven't confirmed that they work exactly the same. So in this case, we're just going to call it yarn-get-dep. So I have packages /star and vendor /star, which are globs. So one of the things that we're going to need to do here is get to this package JSON that we just opened, right? So we could build this Rust binary to be deployed in an npm package. And if we do that, then we'll already know which project we're running in. But for the course of this video, I'm just going to pass in the path to the directory that I want to work in. So the command is going to be something like this, like get dep, project, workspace, dep name. So this is the kind of flow that I want to use. So let's open this in VS Code. I don't need to restart Visual Studio Code unless Rust Analyzer isn't going to work, which is a possibility. I feel like VS Code updates always break Rust Analyzer, but we see it running right here, so we're good. So usually for something like this, I'll use struct opt, but in this case, I think we're just going to go with env-args. So we're going to use standard env. We're going to get rid of this hello world. We could run this right now and make sure it works. I happen to know that it's going to work, so I'm not too worried about it. I'll run it over here for anybody interested, the hello world. But we're going to get rid of this. We're going to do env, or let's say args equals env args. Is this a failable thing? Do I have to? Nope. Doesn't look like it fails. So that, and then Rust Analyzer will be like, hey, you didn't do that import. So we'll import that. So now we have args. Args, I believe, is an iterator. I can check that by clicking on the docs, and it says an iterator. So I don't even need to check the actual implementations because it's right there in the doc string. So because we have an iterator, we can do something like this, right? We can do let project equals args.next. And I just realized that some overlay is flashing all around while I type. That's unfortunate. I'll have to fix that later. But iterators in Rust basically will give us like this next function on the structs that we have. So this is an args struct. If you haven't seen Rust Analyzer, this little type thing is like an inlay. So this is the actual code. And then I can bring the types back, and this tells me that project is an option string because that's what next returns, which I already knew in this case, but it's nice to have. So we've got this args struct. It implements iterator. We can call next on it. So we do that. We can say project, let's call this project dir. We'll say workspace name equals args.next. Why are all those windows popping up? Those should not be popping up. I find those really annoying, so I turn them off. But apparently they got turned back on. Okay, project dir, workspace name, and then dependency name, args.next. So that all works and everything. We're just going to expect here because I want to crash the program. You can't even see what I'm typing with that thing. Okay, project dir. I'm just calling .expect on all of these because if you don't pass in the argument, and because we don't have any like infrastructure set up to generate help text or anything, which is one of the things that struct.opt lets us do, I want to crash, and I want to crash as early as possible. So if you don't pass in a project directory, we're going to crash and say requires a project directory. If you don't pass in a workspace name, we're going to say requires a workspace name. And if you don't pass in a dependency name, we're going to say requires a dependency. I just had trouble. Dependency. My 4th grade English teacher would be horrified right now. Okay, so that all works. I'm assuming that these are going to be reference issues. What am I doing here? What's the actual problem? Cannot borrow is mutable? Oh, right, because next is mute. So really what we need to do here is make args mutable. So we're making the variable reference here mutable. So that when we call next, what next does is it actually pops the thing off the iterator, gives it to us if it exists. And if it doesn't exist, we fail. If it does exist, then args no longer has that in its iterator. So every time we call next, we get the next one, which is why we need to be mutable, because we're mutating the internal data of the args. So this should fail with a different error. Looks like I'm getting a warning. Unused variables. We haven't used them yet. That's all fine. So we're panicking right now. Requires a workspace name. This is not a great panic message. We're probably also not going to implement error messaging right now. So we've got all three of these things, right? And in the project dir, there is going to be a packaged JSON file. So I know from working with Rust that reading in a packaged JSON file as JSON is probably going to take me to Serde land. And Serde, if you're not aware, is serde.rs, SERDE. It is the like big serialization, deserialization library used all across the Rust ecosystem. So when we do this, we want to get the workspaces key out of this packaged JSON, which means we need to read the file in like as a string. So I think fs is the right thing here. So if we do let package JSON, we'll call it root package JSON, and we'll do fs read to string because we don't really need anything interesting here. There are going to be a couple of problems with this. One of which is we're returning an error. The other is that we haven't imported fs yet. So we use serde.rs. You'll see that Rust Analyzer just did that for me. Rust Analyzer is really dope. Is there something else wrong here? I mean, so we haven't done the result yet in the main function, which we do need. Yes. Okay. So the result is the next thing. Result has to return unit in main because main can't return anything. We basically have the option of returning unit, which is these two parens right here. It's like a 0 element tuple, or we can return OK with a unit inside of it. So those are our options, but we can't return anything from main. And then we have like an error here. So let's just see the error message. Type placeholder is not allowed within types on item signatures. So this is called an item in Rust like language terms. Man, I was hoping it was going to give me the error that I needed to put here. There is a specific error. Read to string has an error. Oh, IO result string. So this is going to be an IO result. So we're going to import IO. And that should fix that, I believe. Right, so now we implicitly return unit, which means that our program needs to like return OK unit. So that'll fix our type error for the main function. And then we aren't actually like passing in root package path, like path from project dir. Yeah, so path buff. So path buff and path are very much like string and stir. So if you don't know what I just said, I said string versus stir. I won't get into like exactly how right now, but that is what they are. We'll pass in the root package path, which should work. And then we cargo run and it'll give us the, oh, you know what the problem is here too? If we debug out projector right here, I forgot this happens. So if we debug out projector right here, you'll see it debug out the, all right, I need to debug a shared reference. So we're debugging a shared reference because we don't actually need it, like to mutate it or anything. Requires a workspace name, but right above it, we see project dir, and it says target debug yarn-get-dep. So the first argument in args, when you use env-args, is actually the binary name. So the thing that we actually want to do is just call args.next. Args. One day I'll learn how to spell. Now when we debug out projector, it will give us the directory. I'm going to use -- to make sure that these arguments go to the program that we're building instead of cargo. So GitHub, Christopher Biscardi, christopherbiscardi.github.com. So that gives us the projector right here. We need a workspace name. So the workspace that we're going to test was the dub. And then the dependency is going to be, I am blanking on the name of the CSS, post CSS, because I know that exists. That all works. We can see projector is debugging out the right path now. Let me get rid of this because we no longer need it. We're reading in root package JSON. So let's debug that out because it would be nice to know that we actually did read it. And it looks like we did. I mean, that looks fairly, it's not pretty. It's not really supposed to be. But it is the contents of that file. So now we need to do like something with serde.json, right? We don't care about most of the package JSON. We only care about the workspaces key, but we do need serde.json to be able to interact with this JSON. Yeah, there we go. So it's going to be serde.json from string. So in our project here, I'm going to use something called cargo edit. If you don't know what cargo edit is, this is cargo edit. It allows you to do cargo add serde.json. So when we open cargo.toml, you can see that all of that happened was we added serde.json at 1.0.64. We're probably also going to need serde now that I think about it, because, and you can see that it got added there, because we're going to need to derive like serialize and deserialize for some stuff. So this is going to be the thing that we're going to run. Let JSON equal this, and then the data is actually going to be the, wow, did I already forget this package name? Root package JSON. Root package JSON. And we'll just collapse this. When serde does deserialization, it allows us to specify a type and then like basically does a dispatch to that type to derive the implementation of how to get the JSON out of it. So we have JSON value here now, which comes from serde.json value, which Rust Analyzer just added to my use statements. Super useful. Highly suggest Rust Analyzer. I use it every 3 seconds, as you can tell. So this is not necessarily what we need to pass in. So this says from str. That is not an accident. They are asking for a string slice, which we can get from our capital S string by doing a shared reference on it. So now we have JSON. JSON is going to be a serde.json value representation, which will debug a little bit better. Go cargo run. So you'll see that it has to actually download and compile serde and serde.json because we added them to our project, which is totally cool, totally expected. And you can see that we have this workspaces key right at the bottom right here, which is actually like perfect because I was going to have to scroll up. But you can see that workspaces is like this array struct. So this is a Rust struct or a debug representation of a Rust struct and then a string. So we're going to pull this key out at some point. We might be able to just pull it out now. If I remember correctly, the value struct or the value enum actually doesn't have too many functions on it for like operating on stuff. So object, map, string. I don't really want to do a bunch of unwrapping and stuff here. So instead, I'm just going to be like struct workspaces, workspace package, JSON, workspaces. And this is just going to be a vec for ease in the interest of making this easier to follow along with at home. I'm going to use an owned string, which means that it's a string like you would expect in any other language. So we're going to derive here, and we're going to derive deserialize. If I remember the name of this, it's not going to let me just auto import it. So what is this? Serde serialize. One day I'll learn how to spell. What is the problem with that? What did I do? I did something wrong because Rust Analyzer is complaining. Unused import deserialize. Did I spell this wrong? No. Oh, you know what I didn't do? I opened the cargo toml and I didn't update the serde.j. So cargo has this thing called features. If you're used to JavaScript or something like that, you know that we have multiple versions of JavaScript and multiple ways that different packages can compile and things like that. And in JavaScript, all of that is on you. Good luck, have fun. In Rust, it's built into the package manager cargo, so we get to specify stuff like that. So we can specify the version here. Not going to auto-complete that because it'll blow away my version. And then we have features. And here we can be like features equals derive, and now it compiles with the derive feature. And Rust Analyzer is going to complain. So I'm just going to restart the server. And then we'll run our program again. Oh, features. Did I? Oh, you know what? This is an array. Restart that server again. So when we specify features, there's a way in the code in which you can use macros to decide whether to compile something into the project or not. This is how we use it from the user side. So like this is how somebody using your library would choose to compile it with a specific feature or not into their project. Okay, so that's all good. And then we're just going to make this the workspace package JSON, which should just work. I didn't implement debug here, which is going to be the problem that we run into. Cannot be formatted using, so yeah. Workspace package JSON doesn't implement debug, very specific. The line number dbg is debug macro. So it takes the JSON representation or the debug representation of this JSON variable. It tells us that our struct workspace package JSON cannot be formatted using this. If you don't know what that is a debug formatter. So you got the curly braces on the outside, the colon in the middle with the question mark means debug. So that's an easy fix. We just debug and then we run our program again. Couple unused variables, otherwise looking good. And then we get workspace package JSON with workspaces and packages and vendor. So that's all good. Now that we have the workspaces, we actually do need to go in and find all the other package JSONs. So we're going to do a search for something in Rust that maybe we have like a glob crate. The glob and glob with functions allow querying the file system for all files that match a particular. If we can query for, I hope this will just give us everything. So the star, when you're using the yarn workspaces, means there's a bunch of directories in that directory that then have package JSONs inside of them. That's good for us. Now that I think about it, what we're going to do here is we're going to do a package JSON struct, and I'm going to have dependencies, which is going to be a hash map, I think. We didn't import hash map, so we'll pull it in. It's a standard collections thing. So you can see that we're using a lot of the standard library up here, and then just a couple of serde things. This is what we're going to use when we have to go pull in the package JSON for the deps. Technically, these two structs could be the same struct. I'm not using them that way currently. So we'll have these two. We will need to pass those into something that will get us the directories. It looks like glob is that thing for us. Let's see if it works. Cargo add glob. I've never used glob before, so this will be a first for me. Let's do this, and let's do the glob as the, no, let's not do for. Let's do json.workspaces.iter.map. Is it .map? Flat map. Let's do flat map. Because we're going to have effectively two groups of things or multiple groups of things. So be flat map. Let packages equal this. We haven't collected anything at the bottom. This needs to be imported. We want to return this. So let's get rid of these types for a second. Make it a little easier to read. Workspace glob. And this will be workspace glob. And then do we really want a for loop here? Not really. We want to return a vec, I think, a vec of packages. And then we'll flatten that into a single giant vec of packages, which is why we're using flat map here. So we will glob for that. I assume that this is an iterator. Let's figure out whether that's true or not. This needs to come into scope. You can name modules the same as their crate. Let's see, glob, workspace glob. They only show a for loop. I'm just assuming that this is, yeah, returns an iterator. But what is the error that they were doing here? Okay, glob, result, path, pattern error. So I think we can keep the expect. I don't know what it means for the pattern to be invalid. So the documentation says this may return an error if the pattern is invalid. If that means if a directory doesn't exist, we might have to do something about that. So packages equals JSON workspaces packages. We're going to flat map because we have 2 workspaces that we're going to get all the packages for. And then we're going to flatten that into a single vac. The workspace glob is the name of each of those. So we are going to have to, oh, you know what else we need up here? Package JSON, we need name string, because we're going to have to check that later. So we do JSON workspaces iter flat map, glob workspaces expectors. So this is our iterator. We're going to map. Man, I really don't like those pop-ups. We're going to drop this in here for a second. We're going to call this entry. Entries are a fairly common thing in Rust when dealing with files. So I assume that it's the typical entry and not a like custom thing. I could be wrong though. Let's get glob in here. We do a build. Borrow of moved value JSON. Yeah, that makes sense. We don't need this debug anyway. So now we have the entry. I think that we have to concat this workspace glob onto the path. So we've got the project dir, and then we don't need to glob workspace glob. We need to glob project dir dot join workspace glob. Why is dot join complaining? Method not found in string. Is that because I'm doing, yes, okay. Probably should have just like taken this and done it before, but it's fine. Doesn't matter. We'll just do it again down here. So that gives us a path, which I don't think is the right argument to this function. And then we can do display, I think. I don't think we can do toString here because it's not a function on that, but it is a function on the display. So if we do dot display and then we toString and then we slice it, then we get different errors. Yay! Used after move. Where's workspace glob? Okay, let's do one of these at a time. Cannot move out of project dir a captured variable in function mute closure. So we're just passing a shared reference in. So what happens when we talk about closures in Rust is that this is a closure from this argument to wherever the bracket ends. And what that means is that there are a couple of different traits that you can implement for closures. They pick one based on what they need, which is kind of nice, but it does lead to a little bit of confusion as well. Man, those errors were like not pointing me in the right direction at all, were they? And then this needs to be a reference. Holy, that was an adventure is what that was. Okay, so what happened was because we were using project dir up here and passing it into pathBuf from as a string, a capital S string, and we weren't giving it a shared reference, we were saying like basically this goes away here. And then we tried to use it down here and I don't know, Rust like freaked out on that error message. That was not so the error message I don't think was pointing me to the right place. So cannot move out of project dir a captured variable in a function mute closure. Captured at 24, which is right. 43, and it doesn't even mention 32. Oh, there it is. Maybe I just didn't read the error message. Use of moved value project dir. Move occurs. Yeah, okay, so I've gotten in the habit of like reading the first one and not continuing. I should have continued. Move occurs because project dir has type string, which does not implement copy, which is true. Line 32, value moved here. That would have been the key. Reading that error would have been the key to unlocking this. Let that be a lesson. Read all of your errors. Okay, so let's get back to flat map. I believe that if we just do this, everything will work as expected. So really all I was missing was 1 ampersand up here. So we've got our packages, iter, flat map, workspace glob. We glob for the directories. We join the project dir with the workspace glob, which will point us to the project directory workspace is. We have to turn this into a string because whatever. It's possible that I shouldn't be doing a path here. I don't know what this will do on Windows specifically as like an explicit call out. But I'm not on Windows right now, so I'm not going to test it. Expect unwraps the result, which if we look back here, it was either a paths or a pattern error. And then we're mapping over each entry. The paths iterator is probably, or paths probably is an iterator over entries, unless they have their own type here. So let's just run this and see what we get. Nothing. Why did we get nothing? Right, we didn't collect. So Rust Analyzer immediately, I saw this says impl iterator item equals unit. That's expected, but we aren't collecting. And this is just going to be a vec of whatever right now. This syntax is called a turbofish. That's turbofish. Because collect is so general, and it can sort of like collect into a number of different containers, we have to use this like : thing that looks a little bit like a fish. And then this underscore is just us saying, be like, hey, you know, like just do whatever for us. We don't care. We get a bunch of units as expected because this is, we're like print lining in here and not returning anything. But it does give us all of the packages. And it looks like that is true. I don't know why it gave me DS store. That's unfortunate. I wonder if we can like avoid dot files. You know what? Actually, we don't even need to avoid dot files because I have a different solution that will be a little bit more resilient. Okay, so we have the paths now to each of the workspaces. Each of the workspaces has to have a package JSON inside of it. So when we do this, glob expect map, let's do a filter map here. And then, so that will, in general, work. It won't log anything out because I just got rid of the print lines for each of those packages. But we do have packages and it's units all the way through. So we now have this entry. This entry is not actually an entry like I thought it was. It's one of the nice things about Rust Analyzer is it gives me these types. So it's a result of path buff or glob error. So we have a path buff here. A path buff can be joined with package JSON. And then we can read it in the same way we're doing up here. Now we have a little bit of a problem here, right? fs read to string returns a result. And what we want is if this fails to just return an error. So Rust result and sum are basically 1 and 1. Like no matter what you do, you can turn one into the other. You may lose some information going one way, but that's fine. Okay. This is the wrong page to be on, actually. This is the page we want. So the page we were just on is the module page. So it's standard result, like you can see up here. It's just standard result. And what we actually wanted was the result struct, the type, well, it's not a struct, it's an enum, but we wanted the result type page because the result type page has all of the functions that you can call on a result. So I think OK turns this into an option. So that's what I'm going to do. And then let contents equal this, which is an option now. And then because it's an option now, we can just like dot map over it. We'll say contents, and we will do the serde thing. And serde from string contents. And this is going to be not a workspace package JSON, but a package JSON. So I just went up and checked the name for that we created. So we can name this whatever we want. That is a problem because this is the same thing where it's kind of like it's a result and not an option. When we do that, we can do this flat map. I think flat map is the right thing to do here, right? Serde JSON from string. File read contents. We haven't given it the type here, so it's complaining a little bit that it's like, hey, you know, like you tried to let me do too much inference here, and you need to tell me what you want, because methods like collect and methods like from string, or when you parse something, Rust needs to be told what you want to parse it into, because it could parse it into many different things. And this is the error message that you get when that happens. Cannot infer type for type parameter t. So basically, I can't infer it because there's too many options, is what Rust is saying. So we need to tell it what to do. So we've got match, entry, OK, path. This isn't the cleanest way to write this code, by the way. It's just kind of like how it comes out of my head. So if I was going to share this with other people, I would go back and I would refactor this into something else. So we're going to read string, and this is going to be JSON, and that's our issue. So that infers to option unit, and this needs to be option package JSON. And now we are okay because I'm going to return JSON here. So because we had a semicolon here, we weren't returning anything into this map, which means nothing was coming back. If we remove the semicolon, expected package JSON found option. That's where the flat map comes in, if I remember correctly. So this is serde JSON from string.ok, which returns an option of a package JSON. We are mapping over the contents. Because we're mapping over a sum, we have like one sum inside of another sum. So we have a nested option right here. I think and then is more accurate. So there's a number of functions. The takeaway from this is there's a number of functions that you can use to turn a result into an option or an option into a result. And once you have an option, so once we do this .ok to turn it into an option, which you can see Rust Analyzer telling us right here, there's a function called and then on option types that will give us the contents of the option if there is a sum value. And if there is an error, or in this case, it would be a none, then this closure won't run. So all of that works. And all of that is to say that we should have all of the names and dependencies of all of our package JSONs now. If we have the names and dependencies of all of our package JSONs, we can do packages.iter.find. So I name this package. And this gives us a reference to a package JSON. So package.name equals, what did we call this? Workspace? Workspace name. So we find the one that is the workspace name, and we can just and then this package JSON and the package JSON dependencies.find, or not .find, .iter.find. And that's a hash map, if I remember correctly. So when we iterate over it, it'll give us a key and a value as a tuple. So we can destructure those in the arguments and then do key equals dependency name. Hey, I spelt it correct on the first try. Aren't you all proud of me? Why is that not? No implementation for double reference to a string is equivalent to a string. So the issue here is that we have a double reference on one side and a value on the other. So here we're actually not using the value. So we find it and then whatever. Can we find map here? I don't actually know if find map exists. So find map key equals that. This is a true false. So if key equals that, then we can return the value. I assume this is some. It might be else none. So what we just did here is we found the thing, and when we found the thing, we've returned the dependency version. We already have the name, so we don't need to return the name. We already have the workspace. We don't need to return their workspace. So all of that to say, let semver equals that. If we look at the types, we can see that it's an option string. So we can say match semver, and then have Rust Analyzer fill this in for us. Version, print line, dep, whatever. Let's do some backticks. And none is just print line. Could not find dep in workspace. And this one's just going to be dep in workspace, and dep whatever in workspace whatever is version. Okay, so now when we run this, we should get dep post CSS in workspace dub is semver 8.1.1. So that's it. That's everything that we needed to do. That's how I debug and write Rust programs on the fly whenever I'm feeling like it. This is a little long. So if I was going to, in total, get the version of a specific package that I knew the name of, in a specific workspace that I knew the name of, in a project that I knew the location of, I would just open pipe get dependencies, pipe get post CSS, and then it would show me. So realistically, unless you're writing a larger program that doing this kind of thing in Rust doesn't make sense, if you're really trying to go hacky on it, you can even use something like grep or ack. And then we can just look at the results. And like, as a human, I can tell that one of those is a build script and two of those are dependencies. But if you have a larger program or you want to learn how to work with Serde and Rust and things like that, then this works. So let's go over exactly what we did. Let's do cargo run. Yeah. We do have a bunch of warnings that we could fix. I'm not really going to fix them. But dep post CSS and workspace dub is semver 8.1.1. There's also a node semver crate. So you could do more with this if you wanted to. We might do that on another video. In this case, we used env-args from the standard library. Our main function is returning an IO result because we do a little bit of file IO and we don't really have any other errors. We do args.next because the iterator for env-args starts with the binary name always. So we need to just get rid of that. Then we get the projector as the next one, the workspace name and the dependency name as the next two. These all return sum every time. So we expect those to be a sum value. If they are not a sum value, we try to provide an error message. Normally, if this was a larger program, I'd use something like struct opt or clap, but we didn't do that this time. And then we've got path buffs. We can create a path buff from a string and join it with other things, typical FS module utilities. When we read from a string or read to string, we're pulling in this path and putting it in here as a string. We specify that JSON here is a workspace package JSON, which is the struct that we created up here. Workspace package JSON, workspace's vex string. We implemented deserialize for that, which comes from Serde. Because we implemented deserialize from that, we can use Serde JSON from string with the root package JSON and tell it, hey, we want this as a workspace package JSON instead of like a Serde value or something else. And it just gives it to us. Once we have that, we have the workspaces field on that struct. We can iterate over that. We choose to use flat map because the way that glob is going to return, we are going to have a workspace, right? So over here, if we go into christopherscardy.com and the package JSON, and we get the workspaces, we see packages and vendor, both of which could end up returning multiple results. So like packages has a bunch of packages in it. Vendor has a bunch of packages in it. And what that means for us is that when we map over this workspaces key, which is 2 values, that we are going to end up returning, if we just map over it and we don't flat map, we're going to end up returning 2 arrays or 2 vecs of package JSONs. So to get rid of that, we can use flat map, and flat map will just be like, oh, there are 2 vecs here. Let me compress that into 1. We don't need to manually concatenate or do anything like that. So to create each of the individual or like vecs that have the package JSON structs in them, we go back to the package or the projector. We join that with the workspace glob. Because we're working with path buffs and like globs and stuff really aren't necessarily path buffs. We use display, but it works fine for us. And then we toString it to pass it into glob. This specifically, if you're working on Windows or if you're working somewhere else, you might want to do with something like Camino. Rust. Camino is a way to manage strings a little bit better in programs. So if that's the thing that you care about, think about that. This returns a result, so we expect on it. I should write a little bit of a better glob failed. It's a little bit better. It's better than DERS, whatever that means. So expect unwraps the result for us. Because Rust is an expression-based language, this whole expression here is what's going to get returned from the flat map, which is a vec of package JSONs. And then we collect that into a vec of package JSONs. So it's a little confusing because we're collecting here into a vec of package JSON, which if we weren't flat mapping would give us 2 vecs of a vec of package JSONs. So we've automatically flattened that. After we get the glob, we filter over those. So we use filter map. There's a bunch of like utility functions like this where like if you find yourself mapping and then filtering or mapping and then concatenating or like doing any sort of those processes, you can go find those on the iterator page. And then we create another. So basically we have like the workspace location here, right? Each package. We look for package JSON. We noticed that when we did this, we also got like .ds store. And one of the things that we can do is to try to filter out dot files, right? So we can try to filter out things like .ds store or whatever. The problem with that is that we can have other additional files as well. So like we could have some random file named like thing in the directory. And the glob star would still pull that up. So instead, what we do is we say, if there is actually a package JSON and we can read it, then it's a package. Because that has to be true for it to be a package. And if it's not, then we just ignore it. So when we get .ds store / package JSON, that fails right here when we try to read it. So we just ignore that using OK. We turn it into a sum. We get rid of the error. We don't care that it failed. We don't care why it failed. This is not a valid path. And truthfully, the only way to tell that that's not a valid path is to try to read it. So we try to read it. It doesn't work. We say, OK, whatever. And then we have a sum type coming out of here. So we use and then to map into the sum type. So it gives us the contents that's inside of the sum. We do something with the contents. We say OK again. And that gives us an option package JSON. We ignore this error over here, but we ignore that. So we end up with a vec of package JSONs here. We take that vec of package JSONs and we turn it back into an iterator. So really what we would have to do is like, we don't actually have to collect that, right? We would have to move this semver up to being the other thing, but like we don't have to collect into a vec to find. I'm doing it here because it makes it a little bit more clear. If you have chains that are too long and too nested, it becomes hard to read. So we take the packages, we iterate over them. We find the package name that's equal to the workspace name that got passed in. So when we run this, we pass in the package or like the workspace's root, the project root, then the name of the workspace that we want to care about, and then the dependency. So we find it, find returns an option. We can use and then to get at the insides of the option and operate on them. We take the dependencies, which we defined up here, and serde is taking care of serializing for us. So notice that we didn't have to write any like, oh, if I go into dependencies and then it's a whatever, then I turn it into, we just write the types and serde takes care of it. So back down here, after we've found the package that we're looking for, which is an option of a package, we take that. We go into the dependencies, we iterate over it, we find what we are looking for, and we turn it into something else. So we find the key that we're looking for. In this case, I can rename this to package name, and I can rename value to version. So now we have the package name and the version, and it's much more clear what's happening. If the package name, and we double dereference here because what happens is that iter takes a reference to the thing that we're iterating over. And then find takes another reference. So what we end up with is a reference here and a reference here. So we get a double reference to the package name. We can change this a little bit if we want to. We can use into iter. We could clone. We could do a bunch of things. We don't need to. We just dereference it twice to get the value. So we compare the value of the package name to the value of the dependency name. When we have a successful one, we get some version. Otherwise, we have none. I feel like there's a slightly better way to write this, but this video is getting quite long already, and I'm kind of rushing. So I'm not going to change that. But I believe that there's an easier way to do this. And then we match on semver. So semver is that version, right? It's an option of a semver string. If there's a semver string that matches for the package name, we say, oh, great, got one. If there isn't, then we say we couldn't find one. So if we run this for post CSS, it's like, hey, it worked. Det post CSS in workspace dub is caret 8.1.1. And if we do something like blah, 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 that doesn't exist, it says could not find dep whatever in workspace dub, which is cool. And like we can make this more user friendly or whatever, but this is just kind of a one-off program that I've wanted to write. And I hope it helped. I hope some of the explanations taught you a little bit about Rust. Thanks for hanging out for today's Let's Code, and I'll see you next time.